Did you know? You can receive free poker training through Card Runners by signing up with truly free poker training and registering your Titan or Party Poker screen name. No fees, no deductions, no impact on your points or bonuses. Just free poker training from the best in the business. All you have to do is go to trulyfreepokertraining.com, sign up, and earn enough points to qualify. Even if you don't have an existing Titan or Party Poker account, you can still take advantage of some great deals, like earning a free copy of Hold'em Manager or a free month at Card Runners. Check out our See Our Deals page on our website for more information.
Hi everyone, this is Matthew Jander for Card Runners, and I'm here with theory patch number 1, incorrect calculations in the pre-flop call multiplier. My first theory patch. I've been making theory videos for almost 2 years now, and this is my first theory patch. I haven't been making them at Card Runners for almost 2 years, but over 2 years total. I made them for Stocks Poker before Card Runners. This is not the first time I've been wrong or made a miscalculation. This is by far the longest I've ever had a miscalculation go without me noticing it or someone else finding it and telling me, that I know of. So I've gotten PMs before from small mistakes I've made in videos where I forget to add something or I multiply something slightly wrong, but the mistake's usually something pretty obvious, and whenever someone finds the mistake and they PM me, they know the mistake that I made and they know it was just, a simple addition error or something like that. This is a mistake where I actually did the math the wrong way, and this hasn't happened before that I know of. Usually by the time I get theory content into videos, it's been something I've known about a lot and talked about with a lot of people before, so hopefully the mistakes that actually make it into the videos are very, very small ones and not a big deal. But this one is definitely a substantial mistake. Luckily, all the conceptual parts about the theory holds true. The calculations just made some inaccurate 3-bet defending ranges that we can now improve. As you begin to understand more and more theory, the likeliness that you find something which was incorrect greatly increases. So as I've gotten better at theory over the years, you get less confused about concepts, and as you get less confused about concepts, you start to understand, let's say, turn play better, then it makes the flop play make more sense as you set up your turn play. So as you learn more and more theory, it gets more difficult to really be making a big mistake, because usually, if you make a mistake, something else will be wrong later on in the hand and you'll catch it. So if you understand 15 theoretical concepts, it's going to be more difficult to do the 16th theoretical concept wrong, because if you do it wrong, it will make one of the other 15 theoretical concepts most likely not make sense. My first theory patch, the great thing about theory and math in general is you can actually just straight up be inarguably wrong. It's very hard to prove someone is wrong when people throw out terms like game flow, merging, and fits into my game. It's still possible, but very difficult to unless you understand a ton of theory. So I'm sure you've seen that happen at 2+2 before, where someone who has to, defend his E-rep gets backed into a corner because he gave some awful advice. So he'll say something like, well, I'm merging, or it fits into my game. Sometimes it'll be a really good player making a lot of sense, but the vast majority of the time, it's someone who's making almost no sense at all, and they think if they just, hide behind the concept of merging or game flow, they can kind of get away with it, and they usually can. But with theory, all the math's available for pretty much everyone to see, and if you do something wrong, someone can pretty quickly prove you're incorrect. It's not so difficult to prove math is wrong. In addition, theory will always be useful and get more useful as games get tougher. It's easy to ignore mistakes you made when you played 4 years ago, but the theory you made 4 years ago you plan on continuing to use. Usually you'll catch mistakes pretty quickly, but once in a while, one will evade your detection. This is also why it helps tremendously to talk with other players and always approach theory with an open mind, like you might be wrong, even if it's math with a definite answer. So it really helps to talk with other players, especially for that reason. If you try to teach someone or explain something to someone and that concept is wrong, usually you're not going to be able to explain it very well, and it's very likely the person you're explaining to will ask enough questions where you'll realize it's wrong. But that won't always be the case. So where was the miscalculation? I've used something called the call multiplier many times in my videos, and the concept is very simple. When we defend by calling, the bettor gets to see an additional card, or 3 cards if he gets to see a flop, so his bet folding range gets a chance to be in a plus EV spot on a later street. When bluffing, it is more desirable for the opponent to call than raise, since when the defender calls, the bettor gets a chance to get lucky. The more skilled a player is, the more likely that free card is to be valuable. Skilled players randomize bluffs with the best types of hands, and those hands can usually improve, and skilled players are able to bluff more effectively on later streets. So if you need to watch this patch, you already should have a really good grasp of this call multiplier concept, because I talk about it a lot in my other videos. Usually when you're bluffing, you're hoping your opponent calls rather than raises, because when he calls, you have a chance to get into a plus EV spot on a later street. Whereas if he raises, you simply have to fold. I shouldn't even say you always have to fold your bluffs when he raises, because that's not always true in theory, but most of the time you're going to be folding most of your bluffs, and then when you do have to call with one of your bluffs, you're going to be pretty unhappy about it. You'd rather have seen him just call rather than raise to begin with. The typical example. Let's say we open to 3 big blinds in the button, and the big blind 3-bet bluffs us to 10 big blinds. He risks 9 big blinds to win 4.5 big blinds. If we 4-bet, he loses 9 big blinds. When we flat, he gets to see 3 random cards. This has a substantial amount of EV, since hands like King 5 suited, 6-4 suited, pocket 2s, etc. all have a reasonable chance to improve. I would make a statement like, when we flat the big blinds 3-bet, we may expect him to have an average EV of 4.5 big blinds on the flop, since the pot is quite large and his hand can easily improve, but he's also out of position and against a strong range. Since he loses 4.5 big blinds on average when called and 9 big blinds when 4-bet, if we choose to defend by calling, we need to defend twice as much as we would have to if we defended by 4-betting. Sounds reasonable, right? So the reason why I think no one really ever challenged me on this, or why no one else found the math which is correct rather than the math I was using, is because conceptually this just seems to make a ton of sense. If it's twice as bad when you 4-bet for your opponent as it is when you call, then if you want to defend by calling, you need to defend twice as much. That just seems to make a whole ton of sense, and like it would perfectly work, and you don't need to do any other math for it. At least that's what I thought, and since no one really challenged me on it, I assume most people thought that made sense too. That's not technically correct. What we did in the videos. Let's look at a quick example of defending a 40% button open. We opened and our opponent 3-bets to 10 big blinds. Since he risked 9 big blinds to win 4.5 big blinds, he must defend 33.3% of our range if we only 4-bet. Our opening size, I'm assuming, is 3 big blinds, of course. 40% times 33.3% equals 13.3%. My next step would be, let's say we 4-bet Jack plus / Ace King and Air for 5%. This leaves us with 13.3% minus 5% equals 8.3% of hands, which we still must defend. My final step would be, since we have 8.3% of hands left we must defend, and we want to defend them by flatting, we will defend 8.3% times 2 equals 16.6% by calling, since calling is half as bad for our opponent as 4-betting. Once again, when you're looking at it like this, it seems like it should just make a lot of sense and totally work. It doesn't look like there's anything wrong here. Since we have this range left that we need to defend, 8.3%, we're just going to double it, since calling is only half as bad as 4-betting. But it doesn't work. Why doesn't this work? Quite simply, this doesn't work because we're not just increasing our call frequency. Remember, every time we call, our opponent is expected to lose 4.5 big blinds. We are also decreasing our folding frequency. We are messing with 2 frequencies here rather than just 1, and both have an EV for the opponent which isn't 0. When his 3-bet bluff succeeds, he wins 4.5 big blinds. When it fails and we call, he loses 4.5 big blinds. If we were just altering one frequency, this would work, but how can we just increase our call frequency without decreasing our fold frequency? We can't. So the reason why this didn't work is because 2 frequencies are being altered at the same time. Not only is our opponent unhappy that we called him, because now he's expected to lose money for the hand. He also just doesn't straight up win the pot and win money for the hand. So our fold frequency goes down, which is what he really wanted to happen because he was bluffing and he wants to win the pot immediately. And our call frequency goes up, which causes him to lose more money. So two frequencies are changing here at once, whereas when I did the math, I thought we could just change the call frequency. That does not work. So what should we have done? We opened 40% of our range on the button. We opened and our opponent 3-bets to 10 big blinds. Since he risked 9 big blinds to win 4.5 big blinds, we must defend 33% of our range if we only 4-bet. We now estimate what we think our opponent's EV will be when we 4-bet, call, and fold. Luckily, 2 of these are already defined for us, and the frequency at which we do the other 2 can be solved for so long as we know our 4-bet range. So, when our opponent 3-bets us and we fold, we know the EV of that. He just wins the pot. When our opponent 3-bet bluffs us and we 4-bet, we know the EV of that because our opponent just loses his 3-bet because he folds to our 4-bet. So we only have to guess for the call because the EV our opponent has when he 3-bet bluffs and we call, that's something we just have to estimate. There's no way we can solve for that. Let's assume we 4-bet 5% of total hands. So that's ace, king, and better, jacks and better, and some air usually. So here's the math that we should have used instead. So, if we're 4-betting 5% of total hands, then our opponent is going to 3-bet, which costs him 9 big blinds, and we're going to 4-bet him 5 out of 40 times, since we're 4-betting 5%. So then he loses the 9 big blinds whenever we 4-bet him. So -9 times 5 over 40. Then he also loses 4.5 big blinds when we call him, and our call frequency is what we're going to be solving for. So we plug in x over 40 because every time we call, our opponent is expected to lose 4.5 big blinds when he 3-bet bluffed. Then our opponent wins 4.5 big blinds when he just takes the pot down pre-flop, and he's going to take the pot down pre-flop 40, so that's the total number, minus x, because that's how much we're calling with, minus 5, because that's how much we're 4-betting, divided by 40, so that's our folding frequency to his 3-bet. So we can see here we only have one variable, which is x, and by solving for x, we find out what our flatting frequency would be to make our opponent indifferent to bluffing when his bluff on average loses 4.5 big blinds when we call. Solve the equation. This is done easily by multiplying all terms by 40. We are left with x equals 12.5. We thus flat 12.5% divided by 40, or 31.25% of our opening range. Previously, we flatted 16.6% divided by 40, or 41.5% of our opening range. So we didn't need to flat as wide as I had said in the previous quickie videos, because not only when we flat more is our opponent losing money on his 3-bet bluffs because he now has to take a pot post-flop, but he's also winning less money because he gets to win less pots pre-flop. So that's why this frequency is lower. So here, when we open on the button, we're opening our top 40% of hands, and then when we get 3-bet, we're 3-betting around our top 3% of hands, we're bluffing around 2% of hands, and then we're calling with the next 12.5%, so that's going to be 12.5% divided by 40, or 31.25% of our opening range. How big was this mistake? It depends on the situation. For post-flop, the call multiplier was never even calculated. We simply added on a few extra percent. For pre-flop play, this mistake of making ranges a few percentages too wide is surely something we don't want to be doing. This mistake would have likely become more important when starting to use wide button defending ranges, which is where I noticed it. I noticed it only a few hours ago when trying to make some button 3-bet defending quickies. Thank you for watching, and I apologize for the mistake, but nearly all the theory I do, I have not heard from anywhere else before, and these things are likely to continue to happen. Hopefully they will remain rare, and feel free to ask questions when something doesn't look like it makes sense. That's usually how mistakes in new theory is found. So once again, I really do apologize for this mistake, especially to those people who maybe use the old math to make some ranges that they already have calculated and saved, and now when they see that that math was incorrect, and their frequencies aren't probably going to be very far off, but they probably will need at least a bit of tweaking. I understand that it's going to take time to fix all those, and that sucks. But nevertheless, this is the only time I have had to release a patch in about 2 years of making theory videos, and if I'm just being completely honest with myself, even if I try very hard to not put any mistakes in my videos and to show my math so people can check that math and make sure everything makes sense, there is going to be a chance, especially as I start doing more difficult series, like I'm in the middle of a donking series right now, and then turn play or blind defense play might come after that, and all those series will probably be, relatively difficult with a lot of math and theory in it. It is possible I make a mistake again, so always feel free to keep challenging everything I say, because that way you'll learn better, and then if I'm wrong, the mistake will be caught. And even if I am right, and then you start to understand what's going on, when you start to really ask questions that old theory can't answer very well, that's how you get put in the right direction to go find some new theory, so some new models or some new formulas that work. So, thanks for watching this video. I apologize for having to make it, and good luck to everyone at the tables. Bye.
Want to see your hands in the quickie? Convert your hand history using the CR converter or post it in the forums. Send your link or questions to thequickie@cardrunners.com. Please include all relevant reads, stats, and information. The more info you provide, the more likely you'll be selected.